right, so we're here at the 2013 First Robotics World Championship in the Archimedes division with the dealer and Trevor, Curtis, and Brandon. Team 987, they're going to tell us a little bit about the robot. So can you talk to me a little bit about your drivetrain?
Yeah, so basically what it is we have a 2-sim drivetrain. So it means it's 2 sims on each of our drivetrains. Yep. Basically, it's a 2-speed. So on our high, we go 16 feet per second, and in our low, we go about 4 feet per second. So basically what it gives us is it gives us the speed for the high and then the torque to push people around for the low. And also we are a belt-driven drivetrain. So basically you don't have all the weight of chains and stuff like that because it gets in the way, and also it's really hard to adjust on the fly.
Right, yeah, that's great. I love the belt system. How you doing? So you want to talk a little bit about the shooter?
Well, basically what the shooter is, we got, a basic flywheel here. We have a sensor here, gear tooth sensor, with this steel gear that we made. So with the feedback from this guy as well as our targeting, we can aim this turret anywhere we want to. Now this turret can go anywhere because of the pan and tilt, which you see with the cams, which, there they go. And just a large pulley that we've got there and a Lazy Susan. Regular piston shooter back here, and blocker kind of tapered in crown to keep all the frisbees where they ought to be.
That's great. Do you want to spin the robot around so we can talk a little bit about the ground pickup maybe? I don't know how easy that is. All right. So can you tell me about how this kind of elastic system?
Yeah. So frisbee's going to come from the bottom down here, and what we have are 2 kind of activated bars, if you want to think of it. And because it's got to go up this ramp here, but the side view of a frisbee is more like a straight edge, these fit to the change in shape as the frisbee goes up this ramp. So anywhere the frisbee is in this, it's always getting the push of these belts. So this is just like a Pepsi belt, like in a bottling company. And then these are the regular Vex wheels, but then they're both spring-loaded, as you can see, and shoves it up 6 inches of space. It goes from horizontal to 1.5 feet, raised it up, back to horizontal up here just by jamming it into this guy. So
that's really elegant, very cool. So you want to talk a little bit about your hanger, and then we'll talk a little bit about code?
Sure thing. So with our hanger, you got piston here. I'll show on this side so you can see. So right now it's in the down position, and he'll stroke it out, I think. So you got a 30-pound gas shock here, and when we activate it, the piston here shoots out. This little hook that latches on to the bolt right here comes out, and then the 30-pound gas shock can extend it all the way up. And also, when we drive it into the pyramid there, it's on the shock, so we can't break it. It'll just come back, and then it's like, oh, we're on it, activate it again, pulls it back up.
That's awesome. Very cool. Just want to talk a little bit about the code that went into this very impressive turret?
Yeah, so we have what's called proportional control on both our turret and our tilt motors. We're also using proportional control on our wheel with a Hall effect sensor. It gets feedback from this steel gear that we've mounted to the wheel. We have camera targeting, which also works in line with our point-click targeting and our manual targeting, so all those are integrated into one system. We have an encoder-based brake on our drivetrain, so there's no physical or pneumatic stop. We use an encoder-based stop. And our targeting, I can show you.
Yeah, great demonstration would be great.
Want me to plug in the light?
No, I'll just click and click and I'll move it. So this is an example of our point-click targeting. So when we click and we turn, it'll maintain its.
That is so cool. That is really awesome. Well, thanks a lot for walking us through your robot here, and best of luck to you the rest of the weekend.